So here we are looking at why we have such big trees and so much biomass on an acre of land. And we end up pointing back to some changes in climate. And the one we've already reviewed is mild winter temperatures. So mild winter temperatures allow for photosynthesis year round. And coniferous trees can do it, deciduous trees can't. The shape of the conifers allows for a very efficient reception of that low angle winter light, and the bowl shaped deciduous tree, such as a maple, doesn't. And we said that to maximize nutrient uptake in winter, the needles, by having a large surface area and drying off faster, they can maximize their transpiration, which is necessary to do photosynthesis. And that huge surface area literally means that there can be something on the order of 2.5 times more surface area than similar sized deciduous trees have. So really a remarkable achievement by these trees. They're photosynthetic kings. Okay. Now, the second part of this, you knew it was coming. Summer drought. How could summer drought favor coniferous trees? So summer drought cuts into the photosynthesis of hardwoods more than it does conifers. Here's why. The first piece is the large size of the conifers allows them to store more water in the sapwood of the stem or the trunk. This is an example. About half of a Douglas fir's daily water requirement is met by water absorbed by the roots the night before and stored in the stem and branches. Okay, so that water storage is an important part of this, and also that greater surface area that we already looked at earlier increases their water uptake from fog drip. Summer fog drip increases the annual precipitation by the coast uh, as much as 20% in some areas. And if you've ever camped along the coast, you probably understand that. Okay. And so a lot of those trees, even just condensation from fog too, it's not just the drip, although that's part of it. It's a condensation of the fog itself too. As it condenses, it accumulates on, and then they can actually take that in as well. And that reduces their stress, photosynthetic stress. Conifers lose 15 to 20% of their foliage each winter, so they have a smaller annual nutrient loss than the deciduous trees, which lose what percentage of their foliage each winter? All of it. Conifers recycle more nutrients from dying needles on tree. That's so they're just a little better at recycling the nutrients that are on the trees. They do lose some needles, but as they lose them, they are actually taking that back in even more so than the deciduous trees do. There is some of that happens with deciduous trees as well, though. Conifers need 45 to 70% of the nitrogen that hardwoods need for the same amount of biomass accumulation or growth, and have about half the concentration of nitrogen in the tissues. Okay, so if you just take wood and you look at the carbon nitrogen ratio, it turns out that coniferous trees have a carbon nitrogen ratio that's pretty high, higher than the coniferous trees have, or the needle leaf, or excuse me, the broadleaf trees have. Okay, or the hardwoods, as it were. So let me repeat that again. So basically, they don't need nitrogen, as much nitrogen to grow, is another way of saying that. Why is that important? Because nitrogen is in short supply. Usable nitrogen is in short supply. Yeah, there's plenty of it in the air, but how do you get it into the tree? Okay, and so getting nitrogen in the soil is almost always a limiting factor in ecosystems around much of the world. And it turns out that conifers are way better at that. They're also better at filtering out minerals from the air. Rains leach them into the ground. Okay, so they are then in many ways the conifers. They're basically more efficient, and the summer drought is a big part of that whole story. Okay, another part again is that they can photosynthesize in the winter. That broadleaf deciduous trees can't. All right. So then how do hardwoods survive at all? Okay, you might say, well, if they're so much better, then why don't they totally dominate? Well, there is a great amount of dominance, but it turns out that there are hardwoods that have some advantages in some settings, and so they do well. One is disturbance. Okay, the alder trees. Remember the red alders we looked at? They're very, very good at rapidly colonizing areas like stream banks, where landslides have happened and so on. They quickly colonize, and guess what they do? They have the ability through the nodules in their roots to make associations with nitrogen fixing bacteria, and they're able to actually fix nitrogen and add it to the ecosystem. And so that gives them a head start in areas that are totally depleted of nutrients, or where there's a recent landslide, or a stream bank area with lots of sandy soil that has very little in the way of nutrients in it. All of those things favor the alder tree. That's why you see so many red alders along the streams in Western Oregon, and also up on the the west side of the Coast Hills and east side. And you also see those in the Cascades on the west side, especially here and there on the east side a little bit, for example. So disturbance is part of the reason. There are some trees that handle disturbance better. Another one is succession, and we haven't looked at this one yet, but the big leaf maple is especially good at growing up in the shade. It really is good as any tree, and in some places in the forest you'll find them growing right along with the hemlocks, the masters of shade photosynthesis. And in fact, in the Willamette Valley, you can find almost pure stands or very heavily concentrated stands of big leaf maples, and it's because they were able to grow up through the shade of their own canopy, and no other tree can do that so effectively in some habitats. So that's where you find them there too. And then finally, yeah, and so I mentioned that basically point two is part of point one. The red alder's ability to fix nitrogen helps it in this in disturbed environments. For example, where the landslides have happened, or where, again, stream bank erosion happens. Okay, so here's some of the sources there, just to give you a sense of where I got some of this information, and so that'll explain some of this more as well if you want more detail. Okay, so hope you found this interesting. Have a great one.